Well, everybody, we've been apart for a few days now, and I want to go ahead and revisit some things that have to do with probability. Um, this will be somewhat of a review. Before the break, we got into this in quite a lot of detail, but since it's been a while, I feel, of course, compelled to review it. And by the time you're hearing this, it will have been nearly 2 weeks since we had class. So this idea of probability, the one thing I want to really re-emphasize, and this underpins the hypothesis testing that we'll do before. If I could give you one takeaway message from this beyond all the practical stuff, is that probabilities and proportions are hand in hand. That's so important to mention. And that's why the chapter begins with rudimentary things about probability that have to do with dice and cards and things of that nature. And of course, we end the chapter, the great majority of the chapter has to do with dissecting the normal curve in order for it to be so that we can ascertain exactly what proportion falls where. And we can do that with any normally distributed population that pertains to anything, whether it's IQ scores or needles on an evergreen tree. My old cliches are coming back. So with that in mind, pardon me, I'm just getting used to the software here. Thank you. The role of probability in inferential stats. Probability is used to predict the type of samples that are likely to be obtained from a population. And this is, again, where the hypothesis testing is going to come in if and when we return in April. And even if we don't, you'll see a video to this effect. Probability establishes a connection between samples and populations. Inferential stats rely on this connection when they use sample data as the basis for making conclusions about populations. You'll recognize this from your textbooks, of course. Literally what we're going to do, would you see this thing about a p-value? You remember p-values that you've come across in Psych 200 and other classes. Is the phraseology will be the probability that we observed this sample, that we got this sample mean, given that the null hypothesis is true. We'll just say it one more time. The probability that we got this sample mean, given that the null hypothesis is true. If that probability is very low, given that the null hypothesis is true, then we'll wind up rejecting the null hypothesis. Now, I don't want to belabor that for now, but we'll constantly iterate that phrase when it comes to Chapter 8. Chapter 8 will be quite involved, and I'm looking forward to it. But that probability underpins that, sort of the engine behind it. So let's talk about that. For a situation in which several different outcomes are possible, the probability for any specific outcome is defined as a fraction, of course. So let's get to a particular one. Cards. Here's a deck of cards, of 52 cards. For example, if you're selecting a card from a whole deck, there are 52 possible cards. The probability of selecting the King of Hearts is just 1 over 52, or an ace is 4 over 52 because there are 4 aces. If I could, let me just read this again right from the text. But there are some things that the text expresses so well that I feel the need to say them again. Note that the probability is defined as a proportion or a part of the whole. This definition makes it possible to restate any probability problem as a proportion problem. Again, one and the same. For example, the probability problem, what is the probability of selecting a king from a deck of cards, can be restated as what proportion of the whole deck consists of kings? And of course, it's 4 out of 52. So please bear in mind that those two things are interchangeable because it becomes paramount later. It really does. Here's another one. What's the probability of a spade from a deck of cards? Of course, 1 out of 4. Also could be thought of the proportion of spades in the deck as being 1 out of 4. Or if I'm tossing a coin, 1/2. Half the coin, let's assume it can't land on its side, half the coin is heads, and of course the other half is tails. So, by the way, this needs to be said. To keep probabilities from changing from one event to the next, one selection to the next, we sample with replacement. Now, some events, by their very nature, sample with replacement. For instance, if I roll a die several times, in effect, the sides of the die are restored to the die. They're not taken away as they are with cards. On the other hand, with cards, I sample without replacement. If I'm holding 4 spades in my hand, there are only 9 spades left in the deck of the total of 13 spades. That's sampling without replacement. Generally speaking, we will pretend in statistics as though we're always sampling with replacement. And let me take a break right here. We'll get to the next section in just a second.